Okay, in this question, we have two parts. It's almost the same question, um, but it will remind you of characteristics of a discrete probability distribution. So the first question, number one, is to determine whether the table represents a discrete probability distribution or not. And you are given a table here with x and the probability of x. And so x can take the values -2, -1, 0, 1, 2, and then the probabilities of each of them are given here. So, for example, if I ask you what is, just to understand the table, what's the probability of x equals -1, then you will immediately go to this part, because x -1 is here. You will get it's 0.28 or 28%. So this is just a quick way to understand a table. But you know what? We still don't know if this table does represent or it does not represent a discrete probability distribution. This is the first question. And the second question, number 2, is find the missing value here, the question mark, so that the table here represents probability distribution. Of course, discrete in this case. So let's solve each question on a separate page. First, I will remind you of what are the characteristics of a discrete probability distribution. So here you have the two requirements for a probability distribution. That first one is that the sum of all the probabilities of all the events in the sample space must equal to 1. You can just write it in this formula. The sum of all of the p's, p of x, this, if you add up all the numbers here, this plus this plus this plus this plus this, you should get 1. And the second requirement is that each of them, each p of x, so each one of these 1, 2, 3, 4, 5 values must be between 0 and 1. Probability cannot be negative, and probability cannot be more than 1. It's at most 1, and at least 0. So just remember, for x itself, x can take negative values, no problem with the x. This is fine. Okay, that's fine. X can be any number, any discrete number. What matters when you're looking at a table to check if it's a discrete probability distribution or not is that you first check each number. Now, this first number is between 0 and 1. Yes. This one also between 0 and 1. Between 0 and 1, between 0 and 1, between 0 and 1. So they passed the second condition. Now, the first condition, now let's check. So we add, let's add the p of x in this case and check what we get. So 0.12 plus 0.28 plus 0.33 plus 0.26 plus 0.01. If you do this on your calculator, actually you'll get exactly 1. And so this means that the first requirement is met, and we saw also that the second requirement is met because each of the probabilities, each of the numbers that you see here are between 0 and 1. So this answers the first question, and the answer is yes, because we checked both conditions. Now, the second question that is asking us to make a table into a discrete probability distribution table. So in this case, you see that the numbers here, the numbers that are given at least, are between 0 and 1. So you can say that 2 is satisfied. Of course, I need to make sure that the question mark I choose also is between 0 and 1. But now what matters is that we want to make the first condition true. So we want that when we add up all these probabilities, This is what 1 means. We add up all these probabilities, so it's 0.26 plus 0.28 plus the question mark plus 0.12 plus 0.01. What do we want this sum to be? We want it to be, look here, it has to be equal to 1. So this is what we want. We want this to be 1. So find this question mark. So you can say, therefore, this question mark is just 1 minus the sum of all the other numbers, 0.26 plus 0.28 plus 0.12 plus 0.01. And this will give you 1 minus, if you add up the numbers here, this will give exactly 0.67. And so my final answer will be 1 minus 0.67 will be 0.33. And so I just need to put this value in where the question mark is. And notice that this value also is between 0, so bigger than or equal to 0, less than or equal to 1. So all the requirements are met for a probability distribution, and the question is done.